Everyone. So welcome to 36th edition of this SANOG. We'd like to welcome you all. This is the first time SANOG is going online. So welcome to everyone through this virtual platform, Zoom platform. I can see about 80 people already attending this event. Though we have more than 500, around 600 people already registered for the event. I'm sure some point today they will be logging in and they will be attending this program for tutorial as well as the conference later today. 2020, the last SANOG that we had was in Karachi at Marriott Hotel in January 2020. After that, we had to skip to postpone the event in Sri Lanka, and we decided that the Sri Lanka event would be in July 2021. So we've already had a discussion with our Sri Lankan counterpart, and then the event in Sri Lanka will be from 12th to 17th July 2021. So the Nepal in this we are proud that we are hosting, NPX is hosting this event in Nepal through this virtual platform. Though we would have loved to host it physically and then meet all the participants over here, but the internet has provided us this platform, so we are in a positive side, we should say we are fortunate to at least have this online event and gather together and attend this event and arrange this event. First of all, I would like to thank a few people who've been instrumental to this SANOG from the very beginning to till this time. So a lot of people have contributed to SANOG in building this SANOG to the level that it is right now. We have our past chairs, Gaurav Rajupadhyay, then Norbu, then Jihadul Kabir, who had contributed as the chair of the SANOG. And also, I would like to thank CoreCom for continued CoreCom of SANOG for their continued support to this platform, to me, as well as for having the SANOG community built up over the years. For this event, special thanks to Dr. Phillip Smith, Simon, and Tasi for holding the program committee together, and then thanks to members of program committee as well for holding together to arrange a very good content for this event. Today is the first day of the conference, and we already have few very important and interesting keynotes lined up for everyone, and then few more presentations coming up as well. Over the next today as well as next 3 days, we have various tutorials on routing security, segment routing, and few more. And I'm sure that the participants, around 600 plus participants who are registered for SANOG, would tremendously benefit with this. Also, I would like to thank our community members, trainers, a lot of people I know who have been there with SANOG even long before me, who have contributed significantly to the community. A lot of instructors are there, a lot of volunteers are there, hosts are there from various countries. So a lot of all the community members of SANOG. Also, I would like to thank all the community members of SANOG who contributed in some way to building the SANOG to the level that it is right now. With this, I would also like to, before we go into the keynote presentation, I would also like to take this opportunity to share a few updates about SANOG. As you know, I mean, SANOG, just a second. I think a lot of people who are already here already know about SANOG and what we do, but there are also a few new people who have joined SANOG very recently, and for them also SANOG is basically a platform or forum where we share and discuss about the network operational issues and technologies. And also we do an educate or a learning opportunity for all the community members who are network operators in some way, a part of a network operation of South Asia as well as the worldwide. So it's a get together platform. Uh, we usually do SANOG twice every year. One SANOG would be in around January, second one in around July. But last year we could not do the SANOG July event because of COVID. But and then here we are with the online event this 2021, and hopefully we will do the physical event in Sri Lanka in July 2021. Uh, we go around every country in South Asia. The event happens every alternately in a consecutive way, except for Maldives and Afghanistan. We've had SANOG in every country of South Asia so far. Would like to specifically thank everyone in the program committee. This is the current program committee headed by Dr. Phillip Smith as the chair of the SANOG program committee. We have Simon Voroy and Tasi Funso also in the program committee. From committee members, there's a long list of people who have contributed to arranging the program for this event and contributing with their expertise in terms of making the content and the program even more better, much better for all the community members. We also have a fellowship committee, but headed by Mr. Rajiva. But unfortunately, the fellowship committee could not work this time because it went online. So everyone can participate this time. SANOG, as you all know, we started in 2003 January. First SANOG was in Nepal, then went to Sri Lanka, then India, Nepal, back again Bangladesh, Bhutan, India, Pakistan, and so on. The initial SANOG was the first workshop was in SANOG 2, conducted by Dr. Phillip Smith, and then SANOG 3, we have 2 tracks of workshop. Total events so far is 35, and this is the 36th SANOG. 2 events of SANOG were co-hosted along with Apricot. Total countries that we've hosted SANOG was in 6 different countries of South Asia. Total fellowships that we've awarded so far, 444 fellowships. Total number of workshop tracks that we've done around 94 workshop tracks so far. The major workshop topics, 13 different topics. As you can see, there are like IPv4, V6, BGP routing related, BGP multi-homing related, DNSSEC related, network security, MPLS, a few of the popular workshops that we have been conducting. So we have in India, we have 11 SANOGs so far, SANOG events so far, followed by 6 SANOGs in Nepal. We're not counting this event because it's an online event. Pakistan and Bangladesh, we had 5 times already, and Bhutan and Sri Lanka, we had 4 times. The SANOG has hosted 4 times. So as I said, SANOG 35 was in Pakistan, and then this is a virtual event in Nepal, and 37 is going to be in Colombo, Sri Lanka from 12th to 17th of July 2021. Some of the future plans of SANOG is to build a stronger relationship with the national NOGs, the country NOGs of all the South Asian country NOGs. We also plan to build a regional NOG cooperation among the other regional NOGs. Also, assess the plan was there initially last year also, but because of the COVID, we could not activate few of our plans. We also plan to do a regional instructor. We set up a regional instructor and give them a better exposures. Also, build a stronger community and network operators, and strong communication and relationship with fellows. So we have like 444 fellows who were like, we had provided, or our sponsors have supported to provide the fellowships too. And I think we need to bond those fellows together. I think recently a lot of fellows have formed certain groups, and they've been discussing about various topics. I see some of the groups where I was also a member, and that they have been sharing the various information and various news about various events and sharing their experiences as well. So that's very good, healthy community build up that we have started from this. So with that, I would like to end my presentation. Again, as I mentioned, we have very good presentations lined up. Now I would like to pass on this forum to Mr. Binay Bora, who will be a local keynote speaker. He will be talking about the connectivity challenges of a landlocked countries, especially in the perspective of Nepal being a landlocked country. What are the challenges that Nepal is facing? So Binay, as a lot of community members know, has a lot of experience in the internet segment and has been actively involved with the internet community since 1998, 1999. And he's been a president of ISP Association of Nepal. He's been a board member of Internet Exchange Nepal. Primarily, he's the managing director of Vianet Communication. With this, I would like to hand over this presentation to Mr. Binay Bora for his local keynote presentation. Binay, over to you.
Thank you. Let me share my presentation. So can you see the presentation now?
Yes,
yes, it's visible, right? Okay, thank you very much for this opportunity to speak in this SANOG program. I've last week Rupesh contacted me for this, and now I hastily prepared one presentation for this. Our original speaker had to back out, so I had to be in and speak about our challenges. I'm speaking from the perspective of Nepal, because there are many kinds of landlocked countries, and Nepal has its own unique challenges. So let me talk about our connectivity challenges. Thank you. As you see in this picture, that we 300 years ago we had a unifier of our nation, Nepal. His name was Prithvi Shah. So this king rightfully said then that Nepal is a yam between two boulders. So what that means is Nepal is a very small country surrounded by two giant countries. On the north, we can see that we have got Tibet, China, and on the three sides from south and east and west, we have India. So Nepal is a kind of sandwich between these two huge countries, and this has huge implications in our economy, in our geopolitics, and of course in our connectivity as well. So that is why the great unifier said Nepal is a yam between two boulders. Okay, so if you look at our history of internet connectivity in Nepal, we started our connectivity back in 95, 96 when Mercantile was there. And the only connectivity medium to Nepal was, of course, VSAT, because fiber optics didn't exist then. Even the telephone, international telephone calls from Nepal to outside was through microwave links to India. And those days, the telecoms were not interested in internet at all. And VSATs was pretty much a private initiative with some very helpful government agencies out there then, like RONAST and Nepal Telecom. So VSAT was our first medium, and from early days, bandwidth was only possible through VSAT to Nepal. And rightfully, internet was very, very expensive. I remember paying a very, very high rate for 1 megabit of link, that it was in many, many thousands of dollars at that time. And it was, but what good part was, we could easily set up internet by pointing our VSATs to their respective satellites. And what else was happening was, there was no third party regulation as such, or a third country regulation. Today, when we pass through one country to another, sometimes the regulation of that country comes in between. But when we had our directly looking up towards the sky, there was no regulation then. So that was convenient. But again, the bandwidth was very, very limited, expensive. And even the usage of internet was mostly dial-up and few lease lines here in Nepal at that time. And we had many VSAT providers who were available at that time. I remember connecting my ISP to Loral, and there were like Singtel was a very early one here. Hawaii Teleport did give very competitive rates. I remember PCCW, Thaicom, Mabuhay, and that sort. And there was one other company that I forget now, which was a Tata company, which also provided internet via VSAT. So VSAT was probably a very effective medium in the beginning, but while it lasted, it was great. And after a while, the limitations started to come as internet really exploded in the world. So after the VSAT era, we had in cross-border fiber coming from India in 2008. Once Nepal Telecom introduced that with BSNL, the local Indian provider, they had a connectivity. Then the private initiative also started to kick off. And we had the likes of Whirling, Mercantile, CNC trying to get to the border and get the connectivity done through this fiber. From a capacity of, let's say, around 100 megabits per second in VSATs for an ISP, which was also possible only through a DVB downlink and SCPC uplink. So we're talking about 100 megabits, right, in VSAT days. And then suddenly after we have this fiber coming from cross-border in India, in south of Nepal, today, as we stand, we have more than 800 Gbps of bandwidth being served from there. And most of them is coming from India. Some of it is coming from China, but very little. I think more than 95% of our bandwidth or 99% of bandwidth still is coming from India. And so according to this, you can see that the dependency on neighboring countries for connectivity is the only way. And what we see is from India, we have many points of interconnections, 5 major transit points. And in China, on the northern side, from Tibet, we have 2 points called Rasua and Tatopani. But the problem is those are very landslide prone areas and do get down very often. I mean, it breaks down very often. So the Tibet side is still very patchy. It's not robust yet. So the business case from China is still a challenge. Whereas from India, it has really thrived. And we have a few providers now giving service to us from the border. So if you look at the map, it's like this. The bandwidth is mostly coming to Nepal from 2 points in south, which is Bhairava and Birganj. And we have now, through the power grid, the transmission towers from India to Nepal, we have agreements for power transmission, and fiber do come from there as well. So a place called Dhalkebar and Tanakpur has that as well. So if you look at it, most of the providers are Airtel and Tata are the dominant providers. And we do have some other providers like SIFI trying to come in from the transmission lines aligned with Power Grid India. So this is how it is. In the northern side, you can see Rasua, Gadi, and Tatopani, and which is, as I mentioned, not that robust yet. So talking about the challenges, now we have, because of this, we have a dependency on our neighboring countries for connectivity. So we have all kinds of challenges, as we'll be discussing this. And because we're a landlocked country, very far away from where the real action takes place in terms of content origination and distribution. So Nepal being very far away and landlocked, both has very high implications to us in terms of cost and infrastructure situation here. So that makes, of course, our transit routes long and difficult, and the latencies and bandwidth issues, customer experience, all that is always going to be a challenge here, and we do face that with customers all the time here. And people here have a misconception and difficulty. Even the politicians here, or even the regulators, sometimes do mistake that the reason for being expensive is the ISPs are the ones who put out expensive rates. It's not the case. Nepal has one of the cheapest internet rates, even when it is so difficult and it is so far off. So that is the reality, right? And because of all these things, we've seen no or very little interest from outside party to invest in Nepal. No foreign investment coming to Nepal in infrastructure investment. We do not see that yet. And one of the reasons could be that it's so far off and the investments are so high for the return on investments to come in. And the other thing, of course, is the providers the upstream providers that come to the border for connectivity on the Nepal side are very, very limited because very few have good infrastructure, even in India side. So these are very few, and they come in and the limit.
Hello.
Hello. Hello. Yeah. So that's the problem we see, and there are limited. That makes limited operator means competitive rates are not available so much. So a typical distribution of internet content in Nepal, as we can see, is as you can see that Google has around 35% of our IPT, Facebook has 18%, then TikTok has 7%. So more than 60% is consumed by these three big content providers, and they are the most dominant. I'm sure that's the case all around the world, but also in Nepal, that is the case. And that again has huge implications on how we are consuming this thing, at what cost, how to scale all this content. So these are kind of issues we see here. So if you look at all this content, how does that matter to Nepal now? So this is what I call the CDN challenges. Content. Most of this content are on the agreement between ISP and the content service providers. The content providers, mostly the content originators like Google, they give us servers and we put it in our data centers or in ISP premises. But they do not. There is no internet exchanges in Nepal. So what happens is when this content comes, ISPs end up paying for the transit for all this content to come to Nepal. And that's a huge cost as well. And we do not have internet exchanges yet in Nepal that caters to this kind of business where they could come in directly. Right? So the reason being probably the expensive IP transit discourages providers to come directly. So that is why we have to ISPs here host on their own. And so that means like the content.
Hi, this is Kabir speaking. I guess there is a problem somewhere, the technical issue. So would like to request you to hold on for a couple of minutes more.
Okay.
Thank you.
Thank you, Vinay. I think you can continue.
Okay. Can you guys hear me now? Is it okay? Is it positive?
Yep.
Yeah, thank you. Sorry about that technical difficulty, whatever it was. So as I was saying, the content from the content side, we have three major content originators, like Google, Facebook, TikTok. So what it does is, I've already mentioned that, the last point I was trying to make on the challenges was now these content providers or content originators, they're all over the globe. So is Nepal a priority for them? Maybe not. Do they have a strong business case to be here on a priority basis? Do they prioritize Nepal and all those things? And even in pandemic, we saw that we had a lot of bottlenecks here with the content being hosted here, as it was not enough. The servers were not coming in time, and it was difficult. The supply chain, of course, because of the pandemic, was all over the place. So those are the kind of things that has huge implications on the quality of internet viewing here, because as you can see, all these videos, 60 to 70% is covered by this content providers. So obviously, it's going to have a huge bearing on how the Nepali market consumes the internet. So these are the kind of challenges we face. And one of the examples that was shared by Sumit to me was the TikTok traffic. What happens when even a small tweak from HTTP to HTTPS was done a few months back, and then our traffic, if you look at the graph, is below 10G, and then suddenly it hits 50G. And that huge surge of traffic is coming from the international gateways. Now, do we have the means wherewithal, the economic, the ability to take that? Do we have a business case for that? Of course not. So these are the things that are huge challenges when there are huge surges of traffic. TikTok is one example. Tomorrow there could be something else that is going to be popular, that's going to come in. We may not be prepared. There may not be CDNs ready to deliver these networks. So because of these kind of issues now, it is becoming quite clear where the power lies today and how difficult it is for ISPs to plan anything in terms of traffic management, in terms of scaling the content, and being ready basically to serve the customers with some quality and without buffering, stuff like that. So this is one example. So my last slide, basically, I want to summarize about why, in spite of whatever it is, landlocked, very far away, huge latencies, weak business cases, we should not be mind-locked. And I mean, what can we do going forward from here? So we need to create business cases for CDNs to come on their own cost to Nepali data center and exchanges, so ISPs can peer locally here. For that to happen, of course, the bandwidth rates have to come down. There has to be more competition at the border side. Probably the China side bandwidth from China, it is also very promising. The terrestrial routes to Europe is a very short path, and the traffic passing from China to India from Nepal is another strategic important possibility. That is why we need to create the business cases for CDNs to come in here on their own. And of course, why only the outside content? Why can't there be more local content? So create more local content, and local e-commerce has to go hand in hand. And pandemic has shown us that we see more of that. We see more of e-payments, payments through digital payments. Now, a lot of digital transformation is going on, whether we like it or not, because of the pandemic as well. And local content is also another very, very important step to have more control over the content, about also of the service quality that we deliver to our customers here. And regulation also has to go hand in hand. And the regulatory framework also has to be compelling and attractive for foreign content providers to come in here. Why would they want to come in here and do business if it's not attractive, if it's not welcoming? So those are the kind of things that we ourselves, as landlocked countries, as countries far away, need to sit and discuss with the regulators and come up with something very compelling for these guys to come in here. Also, for Nepal being for whatever, for our goods to move from Nepal to abroad, to the seaports. Similarly, for our content, for our own strategic importance. Tomorrow, we don't know what sort of possibility is going to be there, what cable systems are coming to India. We have less visibility of such things. We don't know how are those cable systems now sort of already oversubscribed. Are there any new cable systems coming in there? We have no such visibility. And of course, we also, even if we know those things, are we in a position to do anything if there is shortage tomorrow? And let's say India prioritize for their own country first before sending traffic to Nepal. If such and such situation occurs, are we in a position right now to be in a position to take help? Currently, it's not. So, what can we do? What does a third country do? We need to explore that to get to the let's say a submarine landing station and have our own cable systems in future. I mean, this is not only about bandwidth. It has other implications, strategic implications as well for a country for their own digital consumption. So this is also important, I think. And at the end of the thing, of course, more competition should be there in the border POI points. We should attract more of these service provider, upstream service provider to come to Nepal to connect, to provide good rates. There's more choices, more competition, and a landlocked country like ours could then benefit from lower rates and provide very, very good quality internet service here. Otherwise, all our time is and all our income is going to pay for this, to pay for all this bandwidth that is going out. And if it takes a large, more than 35% of our income today, if I look at it on an average, is going to pay for these upstream providers. That's a huge chunk. And if you took salaries, the human resource cost, and this, then where does it leave us for infrastructure building? Where does it leave us for the future technologies that's coming in digital medium? So it's very important for a landlocked country to keep in track of all these things. And these are our issues, these are our problems, and of course there are solutions too. And that is why, in SANOG community, we need to discuss all these things and brainstorm and all that. Thank you very much. And that's my presentation.
क्यामेरा कहाँ घुमाइदिइसके त्यहाँ Thank you, Vinay. I think there is some problem with audio and video for some of the people, but there is for rest of the people it's working. So I've just asked the technical team to look at it. If we can just pause for a few minutes, I think I can already see the Santanu online.
Can you hear me?
Yeah, I can hear you, Santanu.
Okay, perfect. Thank you.
Just a second. Let's before I hand over to Santanu, let's wait for 2-3 minutes, and while my technical team look into it, and I can also see if the things are working for some of the people who were not able to see or hear. Let's just pause for 2 minutes. Good morning again. I think Philip and Kavir, I think you guys were having problems. So let's do a test now. Otherwise, we'll just restart the Zoom session. Shantanu, can you share your presentation from your side, or should I share? And if it's visible to others, then we can start. Otherwise, we'll just restart the Zoom again one time.
Yeah, I'm trying to do that. Yeah. Oh my God. Okay, so I have to rejoin because this Mac privacy thing, the Zoom was not enabled here. Let me quickly rejoin in 30 seconds.
Sure.
And I'll share.
Okay. Philip, can you hear me? Philip Smith, Dr. Philip Smith.
Yeah, I just have to find the unmute button. I hear everything perfectly, just not Binny.
Okay, let me share from my side and just confirm if you can see that. Can you see the presentation right now, and can you hear me?
Yes,
perfectly. Perfectly.
You can hear me,
good.
and you can see the presentation as well, right?
Perfectly.
Okay, so why was it not working when Philip?
On my screen here, basically, Binny's share hung totally, right? So normally, if you look at the audio and the video, the microphone setting, all the microphone setting was doing was a slow bounce up and down, and that's a hang.
Yep.
Okay.
Other folks I've chatted to have seen exactly the same thing.
Let Shantanu share the screen now. Shantanu, if you can share the screen now, and we'll just confirm, and then we can start.
Yeah, can you see this?
Yes,
perfectly.
So anybody having any problem?
Outstanding, we're back in business.
Kabirji, is it okay?
Yeah, it is perfectly okay at this moment.
Philip Pipe, some of the people who were having problem.
Sunny, can you see this?
Okay,
Yeah,
I think it's good now. So I'll now hand over to Shantanu for the further presentation. Shantanu is the system architect in Cisco Systems, and he's been one of the pioneers, or one of the people who's actually helped in setting up SANOG to the level that it is now. As I mentioned again, he was the chair of a program committee of SANOG for a long time, I believe. And with this, I think I'd like to hand over to Shantanu to share his experience and the presentation on the outage incident of fully virtualized mobile network and its learning from it. Shantanu, over to you.
Thank you, Rupesh. And before I start, just a quick time check. So is it like 25 minutes what I have, or can you advise?
Yes.
All right, thank you.
20 to 25 minutes is fine.
Thank you. So good morning to everyone, and Happy New Year to all of you once again. So those who doesn't know me, so my name is Shantanu Dasgupta. I work at Cisco Systems as a part of my day job, based out of San Francisco Bay Area. And as Rupesh have said, that I have a very fond, very deep, and very close to my heart association with SANOG since 2006. And it was around 2017 when I relocated to US. I lost touch, totally my fault, and I was missing it so much that I thought that, hey, this is enough. I have to get back, getting together with all of you guys once again so that I can learn from each one of you and share and exchange ideas and do my little bit along with all of you with what we have been doing so far. So it has been, it is a great pleasure and honor for both for me at the moment to be back with you guys, and I can't really wait to get back for the next physical meeting. Hopefully the next one in 2021, the middle of it, we will be back again together. So for the folks who recall my, at least in 2015, 2014, when I was still doing sessions in SANOG and Apricot both, I was covering a new topic that emerged at that time around 2013, which used to be called, or still called, Network Functions Virtualization, or NFV. And that was dealing with how we can virtualize and virtualize different network functions and bring the aspect of cloud into networking. And I was thinking, when the program committee asked me this time that that I do a keynote, I was thinking, should I talk about the journey of NFV for last 7 years? But I then thought it might be a bit boring, and it may be rather a bit more worthwhile to talk about something which is a little bit more specific, a bit fun, and has the operational angle attached to it, given the fact that all of you day to day are operating some network or other in your respective countries and in your respective companies. So I'll try to do my best to outline a major outage incident in a fully virtualized mobile network. And this is where the notion of telco cloud or NFV actually still comes in. And more importantly, we'll see some of the key learnings that we derived out of it. Okay. So quickly about the operator, just for the sake of privacy, I have thought that it may not be worthwhile to call their name explicitly, but they are one of the mobile operator in your backyard, somewhere in the Asia Pacific region. And they also happen to be one of the operator, maybe the only one at the moment, or maybe among the very few aspiring ones who have deployed a fully virtualized and end-to-end automated network, which is running in production right now. This is none of this are myth. This is actually deployed in production, serving real customer traffic. Now, when it comes to the context of virtualization, so far we have seen it happened mostly in the area of core, like voice core, data core, and all the IT services of the telcos. However, these guys, given they did not really had a lot of legacy and they were deploying a new network, they decided we will take this concept all the way to the access as well. In this case, the radio access or virtualized radio access network, vRAN. And we'll deploy mobile edge computing, which is sort of the buzzword right now, where the operators are looking at incremental way to monetize by bringing in new services, leveraging the notion of low latency. Now, this is a network architecture that has multiple tiers of telco data center, starting from core to the region to the far edge, thousands of them actually. And it sort of creates the foundation of a distributed telco cloud, which is end-to-end orchestrated for automated provisioning and automated lifecycle management. And of course, last but not the least, this is, of course, being a new network, fully end-to-end IPv6 based. There is almost no IPv4 in this network, except certain areas where IPv4 is actually mandatory for certain applications because of the lack of application support. Now, the incident itself, fortunately, the incident actually was of very big magnitude, but the blessings in the disguise was the incident itself happened during the user trial phase. Or in other words, the network did not really entered into a full commercial launch phase. So it's in that sense, it was sort of a lifesaver, given the fact that when you see the incident, you'll see the magnitude and the impact of it. And if that sort of thing happens in a real production network, a lot of people will be in real trouble. And the other silver lining was the size of the network was also not that big. There was around less than 1,000 cell sites, which was operational at that time. Things have grown since then. They have like more than a few thousands now, and very soon there'll be few tens of thousands, in another 6 to 12 months time. Now, the incident itself was catastrophic in a sense, like every 2 to 4 days, very unpredictable in the sense of like when it happens from a time of day perspective. Sometimes it happens in 9 o'clock in the morning, sometimes it happens in the midnight, sometime in like evening. So it's completely unpredictable. And the day of the week was also unpredictable. But within 15 minutes of the time, like time equal to 0 to 15 minutes, almost half of the network, half of the cell sites at that time would go blank, complete blackout. Now, you can imagine in your head that an outage like this is fairly nasty in a sense. Like if you think in your respective country or city and think of any mobile operator who are in business, Think of you guys in Nepal as a host country, and just imagine half of the Kathmandu city is completely blacked out. There is no mobile coverage. So you can think of that would be sort of a disaster for that operator. Okay, and that was similar situation here. Only safety net, as I've said before, that it was not really running any commercial traffic that the customer was billing to its end user. So that was the only safety net. But of course, there were tens of thousands of friendly users who were actually testing, trialing the network, and it was pretty severe and became a Sev 1 escalation almost in no time. Now, my role in this project was, from Cisco's point of view, Cisco had played a big role in this project from multiple aspects, multiple parts of the solutions. And I was the chief architect from Cisco side designing this network. And also this operator, when they started their journey, they were very small, like less than 10 people. They did not really had a lot of experienced senior architects or engineers who can design and deploy things. That's not the case anymore, but I'm talking of like 3 years back when this all started. And I, and along with me, a few other guys are also playing the role of one of the operator architect team. Okay, so, and we were actually sort of like helping them design the whole thing and helping them deploy the whole thing. So when things go wrong, obviously they will reach out to us because they know we designed it, so we know inside out what's going on or might be going on, and we can help. And that was the case, where a few of us were asked that we make this priority 1 and jump onto it right now to figure out what went wrong and how we can fix this. Now, before we dive into a little bit more detail of the problem and the root cause of the problem, how we found it and what was causing the issue, a little bit of a basics of the radio access network itself. And again, the objective here is not to get into any details or foundational concepts of radio access. That's a very complex topic, might be a little bit orthogonal as well in this community. But you'll understand the basic concepts here, that just like the OSI model that we all learn in networking, where we have 7 layers, in radio access stack also there are multiple layers. And the lower 3, RF, low-fi, and hi-fi belongs to layer 1, MAC RLC to layer 2, and the upper 2 belongs to layer 3. What's important to note here is the traditional deployment model actually puts all of these layers into a single physical appliance that we deploy at the cell site that we call in 4G LTE environment eNode V, or the legacy 2G environment, we call this a BTS. However, there is a new evolving model which is being discussed. It's not very widely deployed. It's deployed in a few locations at various degree of scale. But this is being very widely discussed at multiple forums in the industry for a while for multiple reasons. And again, the focus is not to discuss on those reasons, but the way the evolving model differs from the traditional model is the evolving model actually promotes the concept of disaggregation and virtualization. And it says that, hey, instead of packing all these layers into a single physical appliance, we can decompose them and create different units, such as the top 2 layers can be used to create a centralized unit. The middle 3 layers can be used to create a distributed unit. And the lower 2 layers can be used to create a radio unit, so that we can virtualize some of it, keep some of it as physical, but more importantly, we can deploy them at different places in the network. Some might go in the cell site, some might go in the pre-aggregation, which in our part of the world in South Asia, we call more the exchanges. In the US or the other part, we call this central office. And some part, like the upper centralized unit, can even go in a regional location, like maybe a few tens in the country of a size like Nepal, if you think in your head. So the reason I'm showing this evolving deployment model, because this was exactly used in this network. Even you recall, I said that this was fully virtualized with virtualized RAN. And the way it looks like that all these components, the RU, which is a radio unit, distributed unit, and the centralized unit, are interconnected with a data plane network, of course. They have to pass user traffic, right to left and left to right, all based on IPv6 once again, but they also have their respective management interfaces, call it out-of-band management or what have you. through which it's communicating to its respective management system, but also a lot of ancillary capabilities, which are sort of a lifeline for making such systems in virtualized environment work at scale. If I'm deploying a virtual centralized unit or a virtual distributed unit, I can't really deal with like static IP address allocation. It has to be always dynamic with DHCP. Or the one system talking to the another system, it's always better to use fully qualified domain names for which I need to have a DNS system so that it all becomes very automation friendly. And of course, each one of the respective management plane interface also have their respective IPv6 addresses, because IPv6, of course, is being used to make the management plane to interact with each other. And the DU and CU, both virtualized in place, are running on top of a telco cloud platform, which has its own respective orchestration, automation, and the operation support system. Now, one thing which you look at here is overall from a systems architecture perspective, a disaggregated system and a virtualized system from a system architecture point of view, once again, typically is more complex. I think that's a unfortunate reality. We just have to be comfortable with it with respect to how you build your knowledge and how you build your tool chains or workflow or your operations processes. Now, from a resiliency point of view, all the systems have been deployed, of course, with all the central and all the core services to be fully resilient. At least that was the goal, that was the intention, that was the design. I have a primary core, I have a backup core in a separate, completely physically separate location. Same for the DNS DHCP, right? Same for the orchestration system as well, so that even if I lose one of the data center, let's say the telco DC1, where all these services are present, the DC2 can provide all these capabilities. And from a systems point of view, we don't really create an outage. Now, keeping this in mind, and again, now it's the time to go to the meat of the session, which is how we troubleshooted and how we identified the root cause and how did the root cause actually look like. And again, the issue itself was every alternate 2-3 days, half of the network is going blank, okay? And we're like trying to find out what's causing this problem. Now, unfortunately, at that point of time, when we were dealing with this issue, and we were like almost 24/7 trying to solve this, and unfortunately, we did not really had a proper tool chain and instrumentation capabilities. Okay, the situation is obviously much better now, but that was not the case at that point of time. And as a result of that, given with a lack of tool chain and lack of instrumentation, you will be dependent on a lot of manual processes or manual investigation. So we sort of try to identify, at least to the best of our abilities, almost all possible elements that can cause failures. And we started checking on each one of them one by one. Okay. However, once we did all the primary checks, we found absolutely no major red flags on the initial check, and also after the log scrubbing of everything that we could have actually gathered from the network. Routing was good, connectivity was good, there was no issues as such anywhere there. Mobile core was functioning perfectly okay, RAN software has no problem, telco cloud platform, orchestration system, everything seemed fine. Now, with all seemed okay, we still can't figure out what's causing this issue. And we lack the tool chain, we lack the instrumentation. Unfortunately, we had no choice apart from waiting for the next outage to happen. And our goal was, we are now jumping after the outage, and trying to find out what might have happened then. And we still can't figure out anything. And we have no other option apart from waiting for the next one to happen. We'll catch it live and we'll check if we can find something more, at that time. And given, if you recall, this was unpredictable. So we sort of like agreed that, we'll be on a sort of a hotline arrangement, and moment it starts again, we'll be on a call in 5 minutes, irrespective of wherever we are. Okay. And that happened. Fortunately, the way we anticipated that, or planned for that, during the next outage, we were able to jump on immediately on the system. And we collected more logs from all potential elements. And once we did that, upon very comprehensive scrubbing that was done, we found some DNS timeouts happening, okay, on the radio unit. Now, why DNS timeouts, or why even DNS? As I was saying before, that all elements, including the radio unit, uses the fully qualified domain name of the respective distributed unit and central unit. Think of like you're taking a router, you have decomposed the control plane and the data plane, quote unquote classic SDN context. And the data plane is trying to talk to the control plane, and that communication in the management interface is using a fully qualified domain name. So that's a very equivalent analogical example to the radio system that I'm trying to explain here. And of course, if I'm trying to resolve the FQDN, I have to make DNS queries, and we saw timeouts. And it seemed like this could be the problem. And just to make sure that we are checking it right, we picked some random radio units that was in the failed lots in that outage. And we put static entries of the respective distributed unit and central unit in the etc host file to avoid future DNS queries. And actually found to be the cause, because in the subsequent outages, all those RUs where we put static entries remained up. And that was our goal. We wanted to put static entries and see if they remain up or they go down. If they remain up, then it's actually the DNS which was causing the issue. So now we were sort of like narrowing the problem space, and we found that DNS is the issue. And then the next step was to figure out what exactly is going on with DNS. Okay, well, what's wrong with DNS? Why this is failing? Now, in order to understand that, this is again a super high-level illustration of how the DNS system was architected there, or supposed to be deployed there. Once again, every single element, the RU, the DU, and CU have their management interface through which they can talk to the DNS. And the DNS are deployed in two data centers, data center 1 and data center 2. And they have a cache DNS, and they also have an authoritative DNS. Again, standard stuff, no rocket science here. And between the RU and the DU, every 10 seconds, that uses the FQDN of the DU at the RU side, and vice versa. The DU also uses the FQDN of the RU to do the heartbeat. Now think of this guy has just booted up, and he's trying to send a heartbeat to his DU peer with an FQDN. He doesn't know what is the IP address. So he sends a DNS query that goes and hits the cache DNS. Cache DNS also doesn't know it. So he queries the authoritative DNS, gets a reply, and the reply is then cached at the cache DNS for 60 minutes. And the response actually comes back to the radio unit, where it is further cached for 1 minute. Now I have the IP address, I can talk to this guy over the management interface. And I'll do that for up to a minute. And after a minute, the cache entry would be flushed. And I will hit the cache DNS, and the DNS should be able to respond from the local cache itself right now, because it's caching that entry. And after 60 minutes, of course, a standard DNS technique, no rocket science here once again. Now, what was going wrong was two things. One, had a bug that the cache DNS was intermittently stopping responding to the DNS queries. And we also figured out that given this network was being built at that point of time, and when some of the initial cell sites were deployed, not both the data centers were active, only one of the data center was active. So those cell sites were commissioned using the name server of only the primary DNS. And when the backup data center came up with the backup DNS system, these cell sites were not really updated from a configuration management perspective to add the backup name server IP address. Okay, that was supposed to be the case, but it did not really happen. Again, it was probably the fault of the process. It was not a fault of any individual. Everybody was working under tremendous pressure. So it was a fault of the process through which we could not really have that configuration check, or call it a configuration audit against a golden parameter that could have ensured that all the sanities are in place. However, all the new sites that came later, they were configured with both the primary and the backup name server. Okay. Now think of a scenario where this cache DNS is hitting the bug and not responding to the queries. And these guys, their local cache is running out after 1 minute. And after 1 minute, they are not able to get any response back from the DNS system. They are not configured with the backup DNS anyway, so can't even reach out to the standby DNS. And they are just going finicky and they're rebooting themselves. And after reboot, it's even bigger chaos because they can't even get some of the basic infrastructure IP addresses because some of the other systems at the back end, which is probably impacted because of all this. So that was the root cause. And again, I mean, looking at all of this, if you see from the overall experience point of view, I think we took 5 major takeaways, and I'll share each one of them one by one with you. Rather, there are 4 here that we took, and the 5th one is I added for you guys as the audience. The first one is the strong knowledge of networking and fundamentals are still very, very foundational. Now, we are talking of a lot of new things in the context of cloud, virtualization, programmability, automation, orchestration, what have you, data modeling, like telemetry, like all these sort of new things. But the foundational knowledge of networking and the design fundamentals, basic philosophies, they are so very important. And it's very important that we solidify all of that and build on top of it. Second, I think this is a no-brainer, and we know this, but I think we need to tell every day to all of, like each one of us, that we need to think about operations in every single stage when we do design and when we do deployment. Every single thing that we deploy, we need to ask ourselves, if I'm sitting in the NOC, how the heck I'll automate this? Do I have the right tool chains? Do I have the right processes, the right systems to actually do that with the right level of efficiency and response time from a feasibility point of view? And that brings us to the point number 3, that to solve the right problem and in the right environment, I need to have our target set of tool chain and instrumentation capabilities. Unless we have that, we'll not be able to hit an efficient operations as an outcome. And this was exactly the case that we were facing here. And had we had a system that would have told us that, hey, there are DNS queries which are failing left and right, looking at a dashboard, the whole process would have been much more efficient and much more simpler, and could have been done by even a level 2 engineer, maybe in the NOC. 4th one, the decomposed architectures, they tend to be more complex. This is an unfortunate reality. Once again, we just have to acknowledge it, and we have to be prepared to deal with it with the right knowledge and the right processes and again tools and everything. Finally, I said this multiple times during my 2014-15 timeframe, and I'll say that once again, that pay close attention to cloud and virtualization in networking. It's happening big time, and it is one of the key future mainstream. I'll stop here. I might have gone a couple of minutes over my time, but thank you very much for this opportunity. I hope this was useful in some way or the other.
Thank you, Santanu, for an excellent presentation. With this, I open the floor. If anybody has any question for Santanu or Vinay, we can type in your question in the Q&A section. Thank you, Santanu, for excellent experience sharing and excellent presentation. That's what basically we need to do. I mean, the basic operations facts. So the basic network operations fact. I mean, the foundation needs to be built, and an understanding needs to be there. So excellent presentation to start the SANOG, I believe, from both the speakers, Binay as well as Santanu. I'll just wait for a few seconds to see if there is any question, and then otherwise we'll close this session for our next session. We'll have a short break after this session. Maybe I think it was 10 minutes or 15 minutes session break. 15 minutes session break. I think since we ran out a little bit longer for 5 minutes, so we'll just have a 10 minutes of break. I don't see any question, so I believe everybody understood it nicely, and then I think it was very informative. Santanu, thank you very much once again. Thanks to Binay as well. So we'll take a break for 10 minutes and we'll come back to join our next technical session where Simon will be chairing the session. We have excellent presentations on Rpki Invalid from Awal, followed by Let's Encrypt automation thing from Phillip Pips, and then DNS presentation from Champika. So looking forward to those excellent presentations again. And with this, I would like to thank everyone for attending this first session. Let me check one more time if no. So I do not have any questions from the floor. So with this, I would again thank Binay and Santanu, and we'll just take a break for 10 minutes. And Simon, over to you for next technical session, where there are, I think, 3 presenters doing the technical presentations. So we'll just pause for 10 minutes. Thank you, everyone, once again. And thanks, Niranjan, for resetting the timer. I think we have 9 minutes left now.
Deepak, can you bring all my speakers to the lobby? They are in the attendance mode.
Oh, yeah.
Rupeshda, can we start?
Sure, Simon. So
Yeah.
over to you for the technical session. Before I hand over, just a quick, as I mentioned again, our supporters for this event are APNIC, Apricot, NREN, Nepal Research and Education Network, NPNOG, and it's hosted by NPIX, and also sponsored by AWS, Amazon Web Services. Thank you. So over to you, Simon.
Rupeshda, thank you. Hello, everyone. Welcome to the technical plenary session 1. This is we named as the operational security session. So we have a very elite panel with me right now. Introducing myself, my name is Simon Soel Baroi. I'm from Bangladesh. And today we have 3 distinguished speakers, Abdul Awal, Phillip Pips, and Champika. 3 of them are really known face to SANOG community as well as around the Asia Pac. So my first speaker is Abdul Awal. He's from Bangladesh, and he is also very keen to work with Rpki. In whole Asia Pac, we know he's one of the Rpki warrior. I found so many emails from Awal and so many Facebook messages from different vendors, different operators to do the Rpki stuffs. So I would like to welcome Abdul Awal and bring his presentation. Awal, the floor is yours.
Thank you, Simon Bhai. I hope you can see me and see my slides and hear me as well.
Awal, we
okay.
can't hear you.
Can you hear me, Simon Bhai? Hello, Simon Bhai?
Yeah, Awal, we can hear you clear.
Okay, thank you. My today's presentation is about about some RPKI invalids that I have found over the years for about 1.5 years in the South Asian region. And there are some interesting information in the slides that I'm gonna go through later on. Basically, the thing is, in South Asian region, there had been a massive growth in terms of RPKI valid routes. But at the same time, though we expected that the invalid routes will be going away, but it's not actually happening. So there are still some invalid routes consistently remaining in the region. So today's presentation my presentation today is gonna highlight some of the cases based on that statistics. First, I'm gonna start with the incident analysis. So in the region, in terms of routing incidents, if you see over 1 year or so, if you see that the number of routing incidents is not gradually decreasing. So there are always routing incidents happening in each of the countries, but some of the countries have done good.
We are having the same issue again. Can you look and check back, please?
So if you see that the graph here, it shows some of the countries are doing good in terms of managing the routing incidents, making it lower. But probably that's because the number of operators there are very low. If you consider the big countries, big operators, then the number of routing incidents are actually significantly happening in the countries. Then in this slide, I'm showing the BGP prefix announcements and their RPKI status for over the 1.5 years. And if you see that the number of not found routes are actually gradually decreasing, which resulting to the increase in terms of number of valid routes, right? If you see the bottom line, that's actually the number of the percentage of invalid routes in the region. So it's always consistently there, though the number probably is not that high. Probably in terms of percentage, it's just 1%. But in terms of number of BGP announcements, it's actually about 600 prefixes. So our focus should be to reduce this 600 invalid prefix as minimum as possible, so that there is no more invalid BGP announcements. What happens if we have these kind of things? One of the very common thing happens in the routing atmosphere is the prefix hijack. So in this example, I'm gonna quickly demonstrate what is a prefix hijack. If you see at the bottom of the slide, there is AS65500, which owns or which has the allocation for 192.168.00/24 prefix, and definitely it is announcing that prefix to the global BGP table, and if everything is okay, probably at the top there is AS64805, we should receive the announcement, and the reverse traffic should go like this. And this is a legitimate traffic flow. But if a prefix hijacker, in this case AS65510, pretends that it owns 192.168.00/24 and announce it to the BGP, that could result to some of the networks making it a best route for the reverse traffic, right? So this announcement probably will impact some of the ASs. In this case, AS64805 is receiving a better path from AS65510, which is the hijacker. So the reverse traffic, instead of going to the legitimate path, probably is gonna go to the hijacker's network, right? So this is one of the common routing incidents happening almost every day in global BGP infrastructure. Now, how we can solve this kind of problems? There have been many initiatives, but recently the Rpki has been accepted by most of the network operators as a solution to this kind of problem. What is Rpki? Rpki actually has two steps. One is creating ROAS, which is route origin authorization for your network. So it is actually a digital object that you create from your MyAPNIC portal or from your hosted CA server, right? It actually consists of 3 parameters that I'm going to show later on. So it's basically your AS number, your prefix, and a length of that subnet, right? So altogether, it creates a digital object, and then this digital object can be utilized to verify BGP announcements or whether the announcement is right or wrong. If you see the diagram at the right side, your ROA resides in a repository, and if any operator wants to do validation, that is checking the BGP announcement with the ROA, cross-checking that, if they want, they can configure a validator. A validator is a relying party software. There are several open source softwares, and if you configure it, then it is going to download all the ROAs from different repositories. And then your BGP router, which you are going to configure for Rpki validation, is going to talk to the validator and collect all the ROAs or VRPs in the BGP router. And then based on that, it will cross-check the BGP announcements. That's called route origin validation. And based on the status, you can actually drop invalids or accept invalids. So how a route or a BGP announcement become Rpki invalid, right? Here is an example of a ROA. If you see on the left side that the ROA consists of 3 things, right? One is the prefix itself. And then what AS number is authorized to announce this prefix to BGP? That is the AS number or origin AS. And there is another parameter called max length, which is which indicates that up to how smaller this main subnet can be divided and then announced to BGP. So for our example here on the left side, this ROA actually covers several prefixes, right? So since we are creating ROA for a /22 prefix and up to /23, that actually covers the prefixes, the subnets. As you see, the green tick, these are valid in terms comparing to the ROA that we have created. The cross mark, for example, the /24s are not covered by this ROA because the max length is not up to /24. With that example, if you see how the validation work, here we are in router R1, and this router is receiving several BGP announcements from its neighbors, right? So let's say on the bottom left, we have an announcement coming to our router, which is 100.100.0.0/24 from my AS number 65500, and my router is gonna talk to its Rpki table. It has a ROA that doesn't match with that prefix, which means it is not found in the ROA table or Rpki table. So for the green one, if you see 192.168.0.20/23, this prefix with that S number is covered by the ROA. So that's why it's a valid BGP announcement. If you see the other 3, which is actually invalid, and how it is it's marking as invalid, we'll talk about this now. So 192.168.0.0/24, though the origin is valid in terms of this ROA, but the subnet size is not covered with the max length. So that's why it's called max length invalid. And the top one, 192.168.0.0/23, this prefix is valid in terms of the max length, but the origin is not the AS number that we have found in the ROA, right? So that's called origin invalid. And combining these two, there could be max length plus origin invalid. In this case here, you see the max length is not that we found in the ROA or the AS number as well. So these could be three different kind of invalids. And once the R1 finds the invalids, it can drop the invalid routes and send only the valid and not found routes to R2, right? The network admin, of course, definitely can configure what kind of route should I accept or what kind of route should I drop. That's configurable. Let's see some example of different kind of invalids. Here I found some of the invalid types, but this I hope they all fixed. They are all fixed by now. So you see, first example here, the S number, the prefix is invalid. So this is invalid prefix length, like I said in the example. The second one is the origin invalid. So that prefix is okay, but the originating AS number, which is originating this prefix is not right. The other one is both the AS number is invalid and the max length also invalid. Some of the example from the real BGP table, you see on the left, you see that two prefixes are not owned by that AS number and they're announcing it. So it's actually origin invalid. All the three examples you see, the prefix is originating from a different AS number that the ROA doesn't cover. So that's why it's origin invalid. The next example here, we have the prefix length invalid. So you see the left side, the right side, you see the ROA has been created with a max length of /22. That means it doesn't cover the /23s or /24s of the parent subnet. On the left side, you see the main /22. This BGP advertisement is actually valid because the ROA covers that. But the subsequent subnets are not covered by that ROA. That's why it's a max length invalid. Though the origin AS is okay, but max length or subnet length is not a match with the ROA. More examples you see on the right side. That one I would like to highlight that a AS number that got a allocation for /32 IPv6 prefix, and it advertised a lot of /48. But it didn't create ROA for that /48 series of /48s, and all became invalid. If you see the percentage of invalid types on the right side, 50%, about 50% of that 600 prefixes in the South Asian region are actually max length invalid, which means the system admin can fix it just logging to their MyAPNIC portal or their membership portal and then just fix the max length, because they're creating ROA with a max length but announcing the BGP routes with a different subnet size. And most of the cases, what happens is the person who manages the APNIC portal or membership portal and not necessarily is the person who configures the BGP. So that's the lack of synchronization between the 2 or 3 persons in the team, right? The orange one is the origin invalid, and the gray one is actually both the max length and origin invalid. The left side, we have a table of countries in the South Asian region. I have 9 countries that I worked with. So you see, because India has a lot of operators and a lot of address space, of course, they have the highest number of invalids, but they're actually doing pretty well over the last 6 months or so in terms of reducing this. Pakistan is the second, and Bangladesh. So you see several number of invalids exist in these 3 countries. So if these 3 countries can reduce the numbers, that would actually make South Asia one of the highest valid routes in the global BGP table. So I hope that will be done soon if network operators realize the value of being valid, or what is the problem with being invalid. Why it existed in the why it exists in the BGP table, right? So first of all, incorrect ROA. That is the biggest reason of being invalid routes in the BGP table. The problem can be solved by just thinking about BGP announcement and making or creating ROA based on that. Then that actually solves the second problem, which is the wrong BGP announcements. And this also can be done, can be reduced by checking the prefixes by the transit providers. Some of the cases, the transit providers do automated filtering, but if they can do validation, which is my third point and very important one, we need to drop invalids by the major network operators. I know this is not going to be done overnight. That's something we need to work together with the customers or ISPs or enterprises before dropping. But the awareness campaign has been done over more than 1 or 2 years, and Rpki discussion has been happening in every parts of the world. So it's time to drop invalid, I guess, because if we don't drop invalid, the invalid routes is not gonna eliminate it. It's not gonna be eliminated at all. It will be there forever. So we need to think about how we can do it smoothly without impacting any certain customers who doesn't know about the impact, right? So how can we do that? First, create appropriate ROA, create based on your BGP announcement. Second, before announcing it, do some filtering so that no invalid prefixes originate from your network. And third one is do validation, right? Validation can clear out all the invalid routes from the routing atmosphere. Here is a diagram. It's kind of just showing you how you can do that. Is that if you're an IX operator, I'm glad that MMIX and NPIX probably dropping invalid. So if you are an IX operator, you can do it in your route server. If you're a transit provider, do it for in your border routers so that the eBGP neighbors can be validated based on the BGP announcements and with the ROAs. And the left side and right side compares if we have the validation or if we do not have the validation. Left side, we do not have the validation, and you see that both the transit providers and the IX operators are actually allowing invalids, and that pollutes the routing or BGP routing table. On the right side, if we have this protected by validation, then the routing ecosystem will be clear, will be having no invalid routes. That's all about my presentation, and I hope I could give you a good idea about what's happening in the region in terms of Rpki invalids. If you have any question, I think I have some time to take. Thank you. Over to you, Simon Wei. Hello, Simon Wei.
Thank you all. Can you hear me right now?
Yeah, I can hear you. As already, have you hear me?
Okay. Well, I guess there is no question right now. If there any question, please give your question in the question answer box so that Awal can answer. Also, we can you can contact with him offline. So our next presenter is Phillip Pips. Phillip is a individual consultant, and these days he's a very known face to our SANOG community. He is also our program committee member. So Phillip, the floor is yours.
Hello everyone, let me share my screen.
And we can hear you too, so you must have read the speaker notes. As upgrade your Zoom client to 5.4.9. Sorry for the PC chair interruption, because the PC chair is very frustrated that presenters are not upgrading like they were asked to do. So please, the other presenters coming the rest of the day and tomorrow, make sure you're using Zoom 5.4.9. Otherwise, most of us cannot hear you. Sorry for the interruption. Go ahead, Philip.
I'm, of course, well known for always following instructions. So, hello, everyone. Good morning. Good afternoon for me. This is a short presentation I whipped up at the end of last year for PACNOG. and I thought I'd reprise it for SANOG because everyone can learn something from this. This is about the Let's Encrypt certification authority, which allows you to get TLS certificates for all your services for free. So historically, getting a certificate is a slightly involved process. You generate your certificate usually by typing some OpenSSL command line, or you click some buttons in IIS, or depending on your software, you might have to jump through some other hoops. But eventually, what you get out of this system is a so-called certificate signing request, which is an X509 file, AZ1 encoded. It's standard format, very easy. You send this certificate signing request to a certificate authority and ask them to sign this certificate for you. And you repeat this process annually. And the step 3 is the one that's always a little contentious. Usually the certification authority, in order to sign your certificate, they will want from you some money. If it's a good certification authority, they will also want some assurance from you that you are you. And this can take different forms. The most common baseline certification authority will want you to prove that you have control over the domain name that you're asking a certificate for. Slightly more thorough certification authorities will ask you to prove that you're actually the organization you say you are. But the bottom line is that you give them money and they sign some integers for you and they give you some integers back. This is clearly a fundamentally flawed system. The certification authorities are answerable first to their shareholders. Their primary motivation is money, and improving security on the internet or individual networks or systems is only a secondary concern to them. But more importantly for this presentation, at least, I could go into the moral problems with certification authorities for hours. That's not helpful. But to the technical community, a bigger problem is that anything that happens annually might as well happen manually, because you're not going to automate something that you have to do only once a year. You'll just put a note in your calendar and do it manually. And this is error prone and easy to forget. So in the course of a year, system builds up entropy. You might forget your calendar, you change calendars, you don't remember the notes. So it's the worst of all worlds. You have to do it manually. It's error prone, it's easy to forget, and at the end of the day your system ends up with a certificate that is no longer valid. It's there's nothing wrong with the certificate per se, but it's not valid anymore because the signature has run out. So enter let'sencrypt.org. It's been around for a while, and what sets it apart from the other certification authorities is that it's not for profit. You can get your certificates for free, and you can also get them automatically, which is kind of nice. Other keywords that they have on their webpage are secure, transparent, open, and cooperative. By that they mean that their entire system is auditable by anyone who is interested, which is again unlike most of the traditional certification authorities, which are for-profit enterprises competing with other for-profit enterprises, so have a vested interest in keeping their systems hidden from public view. Let'sencrypt.org changes all that. You get your certificates for free. They have no profit motive. Their entire business is ensuring that anyone on the internet can get TLS certificates for free. They're secure, transparent, and open, so you can go and look at how they give you your certificates, how the whole thing works, and automatic is another key thing. Let'sencrypt.org only gives you certificates that are valid for 3 months, 90-day validity, which means you have to automate your certificate rollovers because nobody wants to do anything manually every 3 months. So let's look at how this certification process works. At a high level overview, what happens is you're a web server admin or some server admin. It doesn't necessarily have to be a web server. I just stole this picture from their website, and the web server is the example they use. So you, the web server administrator, say that, hey, I'm example.com. I would like a certificate for my example.com domain, please. And the Let's Encrypt server says, well, okay, fine, that's cool. You can say whoever you are, but I would like you to prove that you actually control example.com. So could you please put the string ed98 on a file called 8303 on your web server. And the Let's Encrypt authority is going to sign this with a secret, and then you go and put that file on your web server. You sign the file. You tell Let's Encrypt.org, yes, I've done it. Let's Encrypt.org goes and checks whether you have done it, and the robot is now satisfied that you are indeed who you say you are, or that you, not that you say you are, the robot is satisfied that you do have control over the example.com domain, and it's going to issue a certificate for you. That's very nice. Under the hood is a protocol called ACME, which stands for the Automated Certificate Management Environment, which has been documented in RFC 8555. Go and read this, it's open, and obviously the RFC process is moderately cooperative. It's a JSON-based protocol over HTTPS, which means it's fairly easy to implement. And there are several implementations of this protocol. The reference implementation is something called CertBot, which the Let's Encrypt.org people publish for you. It's a reference implementation, so the quality is like other reference implementations, like bind this to DNS. It has many dependencies. It's, when you install CertBot, it goes and pulls in just about every piece of open source software known to man for you, and it goes and configures it in a way that makes sense to people who develop certbots, and it makes many assumptions about your platform. I'm not terribly enamored of this approach to software development. So in this presentation, I'm going to show you an alternative implementation called acme.sh, which is a really tiny shell script, which has no awkward dependencies at all. In fact, the only dependency it has is you must have a POSIX compliant shell on your operating system, which means any operating system in common use will be able to run the script without any other dependencies. There's many other clients of this protocol. The last time I looked at this page, just before I did the presentation for PACNOG, lists over 100 implementations. So you can go and find one that you'd like. So how does this acme.sh work? You can go and install it. You either just clone their Git repository from GitHub, and you type acme.sh -- install, and it goes and does that. If you're so inclined, and if you trust the ACME developers, which is a reasonable thing to trust, you could just curl their installer and pipe it to shell. And the only thing it does is it copies itself to a directory, it creates an alias in your shell, and it runs a daily cron job to check your certificates and renew them if necessary. Seeing some notifications about questions or things. No, they're not for me. Sorry. So how do you issue a certificate? So once you've installed this ACME client, how do you go about issuing a certificate? Well, that's very simple. You type acme.sh --issue for, do what I mean, -d example.com. Please give me a certificate for example.com. And there are several modes you can run it in. The default mode for running it in is it assumes that you have a web server with a directory on your file system the web server can read from. So, imagining that your web server is listening or is serving files from a home www root example.com, you could run acme.sh --issue -d example.com -w, that path. If you only have your web server listening in your home directory, you can run it from your public HTML, etc. acme.sh also supports multiple domains, so you can have I think the fancy name for that is sans, or subject alternative name, I think is the way it's encoded. You just specify more domain names, and the rest of the incantation is the same. Now that's all well and good, provided that you have a web server. Some of us, feel the needs to go and add certificates to everything we have, not just web servers, but also mail servers DNS over TLS is a popular thing as well these days, so that wants a certificate. What else wants certificates? XMPP wants certificates. My printer wants a certificate for reasons. And all of these things are sitting on the inside of my network, and there's no public-facing web server, and I don't particularly feel the need to go and run a web server. So there's different modes you can run ACME.sh. There's something called standalone mode, which is on machines. You can run that on machines that are still public facing, but don't necessarily have a web server. It requires the privilege to bind to port 80, which usually means you need to run your script as root, which always makes me a bit hesitant. And it still requires that machine to be publicly reachable just to get a certificate. The good news is that it only needs to be publicly reachable for the couple of seconds at a time when you're issuing or renewing your certificates. So you could run standalone modes and hack it a little bit so that it pokes a firewall pinhole, does its thing, and then goes back to living inside a secure box. Alternatively, and this is the mode I like to run ACME.sh in, there's DNS modes where you rely on the DNS to prove ownership of domains rather than having ACME running on every machine where you want to issue certificates. So I've made a little demo. If I can share that window, I can find it. So I've created a shiny new domain. Does anyone see my terminal window? You should be able to see it. I've created there's no dig on this machine drill. SANOG.
Terminal window looks good.
Good. SANOG-36 trouble.is. I've created this. It points at a very exciting part of the internet. It points at localhost. So this machine is unlikely to go and run a certbot publicly visible to the internet. So I use the DNS to point the SANOG-36 to my certificates alias domain, my certbots, which is a magic DNS domain where I can add and remove text records through an API. In fact, I'm running it on Azure, on Microsoft's cloud. There are several other clouds. ACME.sh has little plugins for several DNS servers. You could run NS updates if you run your own DNS server and you want to enable automatic updates. There's the Amazon Route 53. There's even Hurricane Electric's DNS, which just does screen scraping of their web interface. But that all aside, just tell ACME.sh, I would like a certificate, please. Give me a 4K key, use Azure's DNS to add and remove the text records. My domain for these text records is certbot.trouble.is, and the domain name I want a certificate for is that one. And I'm going to press enter.
Philip,
Quick interrupt. Your
Yes.
terminal has disappeared. We only get your slide. Yes.
Yes.
Oh no.
We can see on only slides only.
Oh dear. Just a second. Let me make my
DNS.
slides.
Yes.
Yeah. Let me make my slides not full screen. If I do that.
Yes.
And then I go to my terminal window. Is it back?
Not yet.
Okay. Let me stop sharing and start sharing again.
Philip, probably you have to share the full screen. You are sharing only PowerPoint.
That's what I thought. There we go. Let me share that full screen. How do I share the screen? I could do that. Share the screen. Oh, there. How's this?
Perfect.
Good. And okay. And everything broke because I don't know why it broke. It's telling me why it broke. Oh, it's telling me it broke because I can't actually type. Okay, I did something stupid in my DNS. Oh, yes, I see. It helps if I type it right. There we go. Nobody saw anything. So now it's going to work. So u.trouble.is is a subdomain I have for my apartment, and that host name did not exist. There we go. This one does exist. So what's the shell script is doing is it's requesting a certificate for SANOG-36.trouble.is, It's adding this magic text records to by DNS using Azure's API, which I treasure my ignorance on. And it feels, success, hooray. The robot has gone and verified that this DNS record exists. It then goes and cleans up the DNS record again. And lo and behold, at the end of this 20-second long process, a certificate falls out. That's very nice. Let's go and look at the certificates. If I, we can take a look at the certificate using the usual OpenSSL intuitive command line interface. OpenSSL, there's not minus x509 minus no out. That file minus text. We can look at that certificate and we see that it's a signed certificate. It's been issued by Let's Encrypt, and it's valid from the 18th of January, 5 o'clock in the morning GMT, which is nowish, and it's good for about 3 months, and then it will expire and need to be renewed. And there's the certificate underneath it. So this is running purely on my DNS server. The SANOG-36.trouble.is host obviously has no internet connectivity because it's localhost. And I have a certificate here that is now usable for the next 3 months. Let me just go back to my slides for a moment. If I can do play from current slides, there we go. In case. So how does this work? As I talk you through it, it verifies the domain ownership by checking for a text record. The reasoning is that if you own this domain, you control its DNS, and you will be able to add a random text record on request. This is the same way that Google Postmaster tools work, or Keybase, or there are several other services that just put a text record in the DNS to prove to us that you own this domain. So the nice, cute thing about Let's Encrypt.org is that it supports indirection. You can CNAME a verification domain. You can tell Let's Encrypt.org that I will outsource the DNS fiddling to some other service. So I CNAMEd my verification domain to Azure, who have a nice API, and it's allows me to use their API for one thing, which is convenience. For another thing, it's secure. I don't need to go and configure my DNS server to enable automatic DNS updates. I can just carve out a CNAME out of my domain, in my case, certbot.trouble.is, point it at Azure, and the attack surface is limited a bit. I could use NS Update and self-host, but Azure is just easier. The ACME.sh has any number of other DNS providers. I think there's about 20 of them that just work, going from NS Updates to Azure to Hurricane Electric to, I don't know, GoDaddy DNS and Gandhi DNS, and it works. ACME will now regularly renew this certificate for me. So there's a cron job running on my ACME system, which every day it goes and checks, does any certificate need renewing? If so, it goes and tells ACME.sh or the Let's Encrypt.org robots that I would like to renew my certificates, which works in the same way as issuing a new certificate. Create a text record, check that it exists, remove the text record again, and you get a new certificate out of it. So that's kind of nice. So the way I've got this set up in my DNS is I've got certbot.trouble.is is directed at Azure's DNS, which has their API. And then I've obviously not updated these slides since PACNOG, where you see PACNOG here, we mean SANOG, and where you see 27, we mean 36. So I've created SANOG-36 A records pointing at legacy IP localhosts, quad A record pointing at IPv6 localhosts, then X record pointing into the void, and then I have this CNAME, this magic CNAME, underline ACME minus challenge dot SANOG-36 is CNAMed to underline ACME minus challenge dot certbot. So that goes to Azure's DNS if I can add a text record there, everything is good. There's a lot of pointers to more resources. If you want to learn more about let'sencrypt.org, you can go to let'sencrypt.org and read everything. Missing from this slide is the RFC. You can go and read the RFC 5888 for everything you want to know about the protocol and more. And acme.sh is on GitHub. It's a small, tidy shell script. I think the wiki is probably, the text on the wiki is probably much more than the text inside the shell script. So it's extremely well documented, and the code is actually fairly easy to read as well. If you have any questions about this, or you want to go and deploy this and it blows up in your face, well, you get to keep all the pieces, or you can send me email and I'll be happy to provide moral support and maybe even help. I'm happy to answer any questions.
Yeah, thank you, Philip. Thank you for the nice presentation. We have only one question. The question is from Subhas.
Yes.
Would you like to share us how handy it is for key change?
Key change is in if you want to change the key, or what you mean by key change? You want to create a new key. Creating a new key is just issuing a new certificate. So you just do acme.sh -- issue again, and it will change the key for you. So that's easy enough. I see a second question about Ecdsa certificates. Yes, let'sencrypt.org supports Ecdsa certificates. I don't know if I've answered Suvash's question right, if that's what you mean with key change.
Probably Subhas can contact with you offline.
Yes, send me email. I'll try to reply to it.
Oh, he answered yes. Okay, thank you, Subhas.
Hooray!
All right. Thank you, Philip. Thank you for your nice presentation. Thanks again. Thanks for helping us in the PC. Our next presenter is Champika Vijayatunga, very common face and very old friend of SANOG, and he's also a core com member of SANOG. His day job is with ICANN, and he's always working with DNS, and we found, so many of us found him in the DNS and DNS security tutorial, and as well as DNS workshop. So the floor is to Champika. Champika, can you please share your slides?
Thanks, Simon. Let me share my slides. I hope you can hear me and see me. Can you hear me and see the slides?
Champ, can you talk?
Yes, I'm talking. Hello.
It looks like we have another version problem.
Yes.
I fear. So those folks who are on older Zoom clients will probably see this all just fine. And those of us using new clients cannot.
Okay, I guess at least some people can hear me, I believe. Philip, can you hear me? Hello.
Hi, Champika. Champika, it seems there's some version-related problem with Zoom. Some of the people with new version cannot hear you or see your presentation. Would it be possible for you to upgrade your Zoom? I think
I have upgraded, and it says I have the latest version.
Is it 5.4.9?
547.
549 is the latest one, Champika. Can you check? It'll just take a minute, so that I think rest of the people who cannot.
Yeah, but only thing is Yeah, I may not be able to do it now because that need to be, because I'm using our office laptop.
Oh, okay.
Yeah.
I think in that case,
So,
let's go ahead with this then.
okay. Can you see me and can you hear me?
Yes, I can see you and I can hear you. But those who so
What do you want me to do? I mean, it's close to lunch as well, so I could maybe give a try during the lunch break if you think that that's a possibility. I don't know. You can tell me what to do. Should I go ahead with a few people?
Let's go ahead with this presentation. I think because if it takes time for you to do that, then let's go ahead with it. But otherwise, it just takes...
because it was telling me I tried to update, of course, and then it says that I've got the up-to-date version. Yeah.
Oh, okay. Let's go on. Let's continue then.
Shall I then continue?
Let's go ahead. Let's continue.
All right. Okay. Yeah. Sorry, everyone. In case if if anyone cannot hear me or see me, hopefully maybe at least some number of people can go through this presentation, and maybe if there is any later, if there's any recording, maybe this can be shared. Or if there is any question, feel free to contact me later. So in this presentation, I want to mainly highlight about the DNS abuse handling aspects, and also securing DNS from this presentation, basically. And let me just try to quickly go through some background information related to the why we really need to consider handling DNS abuses, because there are a lot of security threats related to DNS. I'm just trying to actually go quickly given the time factor as well. As probably you know that DNS was designed quite a long time ago, probably around 40 years or so. So during that time, during the design of protocol itself, there were not much of the security aspects were built into the protocol itself. So for example, there are issues in a way like the data when it comes to data integrity, it is not being really handled by the protocol itself. So we have to have different other security mechanisms to protect against such data corruptions. And also confidentiality aspects. As you know, again, in the protocol itself, the data goes clear in clear text, so the attackers can see the and so on. And there are, in general, the DNS is pretty complex system because there are several parties involved in managing DNS. There are several stakeholders involved. So there are lots of complexity in the management of whole system itself. This is also one of the reasons for a lot of abuses as well. And then there are also namespace risks involved. I've given some example here just to show you. If you see these two examples, example.com versus this example, this example.com string is not an ASCII string. That's IDN based string, but for a user it looks pretty much same. But actually the DNS gets resolved based on this ASCII string, which is in the brackets. So but unfortunately for a user, especially if you're looking at from a mobile screen or something, you may not be really able to identify the difference between these two domains. So there are a lot of these type of namespace risks as well. And then we do some typing mistakes and so on, so we can be easily go into different domains, and then those things can be also used as for abuses. Now trying to also actually go further into some of these further security issues. There are a lot of redirection abuses happen. For example, that the user is being taken to an authoritative server that is controlled by an attacker. This is possible. And similarly, the user also can be actually taken into a resolver that is being controlled by an attacker. So this is pretty much hijacking issues. So these things are pretty common in DNS. Then there is denial of service or DDoS type of attacks can happen mainly because there could be some operators who are not really properly managing or maintaining their resolvers. Things like, they could be providing open recursive resolvers, or there may not be some proper security controls, access controls in the recursive resolver level. So these sort of issues can happen as well. And also the other thing is that DNS space is quite hierarchical. And because in case if the higher level domain is compromised, then there is always possibility then the lower level domains can also be compromised as well because of the hierarchical layered approach that we have in DNS. And then going further into a lot of other compromises do happen related to the registrants, registrars, and registries as well. This is mostly because of various type of phishing attacks, or there could be some email sort of compromises that can happen as well. Things like business email compromises and so on. So in such incident, if there are some compromises do happen, then the registrants can be compromised, as well as registrars, and registries also can be compromised as well. And if the credentials are being compromised, then obviously the attacker can go and change all those credentials, name server settings, mail server settings, and things like that in the registrar systems. And then this can lead into more complications and more vulnerabilities as well. So this is also why things like registrar locks are quite recommended as well. And also there are a lot of other abuses. Security threats do happen with related to the software vulnerabilities. So we should not be really having same sort of DNS software in all our name server across all our name servers as well. So these are, in general, some of the common threats that I just wanted to, share, and the abuses that that do happen nowadays. Now, I just want to, quickly go through some DNS abuse handling initiatives that are being happening, over the last few years as well. And some of these things, of course, there are a lot of updates that has happened in the recent times. And also there are various ways as community that you can also be involved in these projects. So I just wanted to give a very quick update on that. One of the thing is the domain abuse activity reporting system. Simply, we call this as DAR. So this has been happening for the last few years. Now, DAR is actually a system that basically go through all the generic top-level domains, because zone files basically, because ICANN has got contracts with the GTLD registries, and also there are some voluntary CCTLD registries as well, who actually share their zone files as well, so that we can go through those zone files and then see what sort of abuses happening in those domains within those top-level domains. So, and then this can be reported back to the community. So currently there are monthly reports coming up. So if you go to this below URL, you can see all those reportings that comes monthly. Now, there are 4 areas we consider in terms of abuse reporting here. One is phishing, and then botnets, then malware, and then spam. And also actually, we do get a lot of feeds from a lot of RBLs as well, reputation lists and so on. And this also includes a lot of historical studies and so on. So, and then these these approaches are all transparent and it is reproducible. It's all published, and you can also use these for reporting. And also, if you are a TLD, in case if there are any TLD operators here, or in case if there are some CCTLD operators who are actually volunteering into this, you can also actually see this type of abuses happening in your zone as well through this system. So this is what we call DAR, and then just wanted to show you some sort of abuses that you can see through DAR here. So you can see, I've just taken few graphs just to sort of give you an highlight, but then there are a lot more. If you really refer to a monthly report, you can get more details with regard to these abuse domains. So also you can see the number, in this case, you can see the number of domains identified as with some security threats over the time. In this case, I've considered the last year statistics, because this is based on the December 2020 report. And then similarly, you can also see the abuses between the legacy top-level domains versus the new generic top-level domains as well. And then the type of abuses that I mentioned to you earlier. If you see this pie chart, you can see actually a lot of abuses do come from spam-related issues. So almost like 85% or so in spam. And then we also see botnet and then phishing and malware as well in some percentages over there. And also you can see, if you can zoom into each and every of those different types of abuses and see the trends and so on. Now, if you analyze this over a period of time, say, for example, in this case, because the system has been there for like 3-4 years or so, in the last few years, we can see the trend. If you see the trend, pretty much, phishing, malware, command and control type of abuses have been in the increase in general, the trend. But we have seen some decrease of trend in spam. So you can see the spam has been decreasing, but the other malware, botnet, and command botnet, and then phishing sort of abuses are slightly on increase gradually. Mostly also this could be because, of course, a lot of operators, they have their spam filters and things like that. So generally the spam is being pretty much handled quite well, but then still there are other related abuses do happen. Another project which is also happening is something called ITHI. Simply ITHI stands for Identifier Technologies Health Indicators. So here what we are trying to do is actually we have some certain indicators or matrix that we could consider to measure a certain over a certain period of time and see whether how this abuse is happening. Are we doing better or are we doing bad and things like that. Now for this type, for this project also, actually if you're ISP, university, or if you are operating DNS resolvers or authoritative servers and so on, you can also participate, and because we can have some probe systems and get some ratings through those as well. Now, by the way, now we do not collect any of the PII type data here, and so this is actually more generic data related to the TLDs, of course. And then and also these things are all published. Now I will also show you, actually, if you go to this URL, you can see more details of this project as well. But just to sort of give a snapshot of things that what you can also measure or trying to understand out of this whole exercise, you can see the traffic that is actually based on the traffic that goes to the root servers, because I can also manage root servers as well, IMRS, or I can manage root servers. So we see that a large percentage of traffic that comes to the root server are NX domain type queries, and because there's no answer for those. And then we can also measure things like things related to the DNSSEC deployment as well. And also you can see there are lots of name collision issues because some organizations who are using certain domains internally, those domains also that then pretty much get leaked out, and then you can still see TLDs like .local or .home and things like that in the DNS queries as well. Certain percentages we can see over there, and we can also measure things like resolver concentrations. That means if you consider say 50% of the DNS queries are going through about how much of percentage of resolvers, or 90% of queries go through how many of resolvers and so on. So in this way we can also measure the concentration of those resolvers as well. And then as I explained to you earlier, we can also measure the DNS abuse through the DAR system as well, and this also feeds into the ITHI metrics as well. So this is kind of a snapshot that you can see, and for more information you can actually go into that URL that I shared. There are some further community work that are happening related to the DNS. There is also an initiative called Domain Name Security Facilitation Initiative, or simply we call DSFI. Now there's a technical study group. I mean, this is basically a community group. Probably you know that Rpki, I mean, she's the coordinator, and then there are several other members from the community as well. So they they analyze, they actually provide a lot of recommendations in related DNS security to ICANN as well, based on this initiative. And then among the ICANN contracted parties, which means like registries and registrars out there, there are some DNS abuse work happening. So in case if you are a DNS registry or registrar provider, you can also actually be part of this project as well. If you go to DNS abuse framework, there is a framework that is being defined, and then you can also be part of this as well. Finally, I thought I'd share some DNS abuse happening during this COVID-19 period, because we are all into the COVID-19 now. And so the methodology is actually designed based on trying to identify the suspected domain based on various factors, and so here we have obviously based on those zones, we have looked into various COVID related keyword patterns, and seen what sort of abusive domains are being created over there. So this also can be, not only just the regular names like COVID or Corona and things like that, but also there could be some variants of, based on IDN type domains, or other strings that are similar looking to these ASCII-based strings and so on. So based on these, during last year, pretty much, during the year, we have seen like 248,000 or so domains identified in this blue line. There have been some suspected, cases with this, but then during the half of that year, from May to November, about 150,000 of those found with some sort of misuse. In the red line, you can see actually the high confidence reports based on all these analysis that has been carried out. And these, based on the high confidence reports, we have seen around 2,500 or so high confidence abuse cases coming from these domains. Now, these are being, of course, reported back to the registries and registrars, so they can actually attend to those. Generally, we have seen some breakdown in terms of breakdown of keywords in terms of identified domains. In this case, related to the abuses, we have seen 60% of the domains included these 4 keywords like COVID, mask, Corona, and virus. So these counted for 60% of those abuses as well. And then, there are other words and also from different other languages and so on. And so one of the things I just wanted to actually before I wind up, just wanted to consider you that deploy DNSSEC, because this is also, if we can implement DNSSEC, we can avoid a lot of these issues, things like phishing attacks and many of those attacks that I went through earlier. And just to give you again a highlight from a global and a regional perspective, or if you do a comparison between all top-level domains versus country code top-level domains, you can see that currently, there are about 1,500 top-level domains. Out of that, about 1,300 plus top-level domains, they have deployed DNSSEC, and they have also sent their DS records to the root. So it is published in the root, and so that's almost like 90%. Which is pretty good. But then still there are about 125 top-level domains. This is mostly the CCTLDs, country code top-level domains worldwide. They have not deployed DNSSEC. So this is something to consider. And then from a CCTLD perspective, again, it's pretty much the number of CCTLDs who has not deployed DNSSEC. You can see there are 124 out of 308 CCTLDs worldwide. Now, focusing on to the Asia Pacific statistics here, the CCTLDs in the APAC region, you can see that around 69 CCTLDs. Now, this includes, of course, the countries plus the territories who has got top level who has got CCTLD domains, and then 69 of those they have deployed DNSSEC. Whereas about 40 something CCTLDs, they have not deployed DNSSEC. So this is something, especially if there are some operators who are considering to deploy DNSSEC at CCTLD level, consider this, deploying this, so that even the operators, second level domains under you can also deploy DNSSEC. And so these are some sort of snapshots for you to get some idea about the DNSSEC deployment as well. I think that's all I wanted to actually quickly cover in terms of different types of DNS abuses, the security issues, and also various projects going on, and how as community, how you can participate, and also especially from a DNSSEC point of view, the importance of deploying DNSSEC as well. And thank you very much. And if there are any questions, I can take now or even later through any chat. Thank you.
Thank you, Champ. Unfortunately, some of our guests couldn't see your presentation. Probably they can download it from our website. We will upload this presentation soon in our SANOG website. Thank you, Champ. Thank you, Philip and Awal. Okay, we have one question, Champ. Could you please answer? It's from Subhas.
Okay, let me just have a quick look. In terms of best practices, obviously, there are a number of best practices actually even highlighting from this presentation itself. Consider not only just one aspect of your DNS infrastructure, you look at it as a whole thing, because DNS is a public facing infrastructure. So this can, sometimes you could be a operator who operates, say, recursive resolvers as an ISP. Sometimes you could be operating authoritative servers, and then you could be also actually running some other DNS services. So whatever it is, you just have to actually consider the overall picture and then try to protect different aspects of your DNS infrastructure. And remember that DNSSEC that I mentioned to you is only about protecting DNS data. That's all, right? Deploying DNSSEC does not mean that the whole DNS is actually secured. you still have to consider various other aspects, as I told you earlier, because DNS is not just the DNS data itself, then there is also DNS servers and generally the cyber hygiene itself. So I would say, the best practice would be actually consider the overall infrastructure itself, and then it could, even from your hardware to soft DNS server software to proper management of servers, services, and then the monitoring aspects, everything together. So consider the whole thing together, and so that would be a better practice, I would say.
Thank you, Champ. Subhas, thank you for your live participation. I guess there is no question. I didn't find any question in the Q&A box. So thanks, Champ, Awal, and Philip for your presentation. And thank you all. Sorry that for this version mismatch, some people of us, we couldn't see the presentation. Probably we can collect it from later on. So our next session will be after the lunch break, and that will be done by Paresh Khatri, and that will be technical plenary 2. And we will start that one from 1 p.m. Nepal time. Thank you all.